Alright, well, we're a minute or two early, but I mean, like, I don't mind getting started if you guys don't. So again, I don't really have any lecture today. Really, I'm just here to answer questions that anyone might have. So I have the study guides all pulled up right here, so I can go over any topic or answer any questions. If you got something about the homeworks or about the past exams or anything like that, feel free to ask. Again, you should be able to review your past exams, so you should be able to go on to Canvas and go through them and answer any questions or if you notice anything. Also, I'll be back here on Friday if there is interest in it, because, yeah, that's it. And then just a reminder that our final exam is going to be between this Friday and Saturday. It'll be open for 48 hours. You'll have any time during that window to take the exam. It'll be virtual. It'll require the Respondus Lockdown browser plus webcam. If I've already discussed with you other things, please just send me a DM on Discord or an email so that I have it in writing just as a reminder for my brain. Yeah, so that's kind of all my preamble. So do you guys have any questions for me? Any place you want to get started? Yeah. Yeah, it was a Python program.
I didn't get the right answer, like, fully, but it didn't tell me what the actual right answer was. I was wondering if you could walk me through that one.
Yes, I can. Hang on, give me a second because I just got to pull it up. And I have the slowest computer alive right now, so that'll just take me a second. Yeah, I can take that out and go through that. That's not what actually it is. Okay.
Are we going to have to write regular expressions?
Right, what?
Write regular expressions?
No. You may need to read some basic regexes, but you won't have to write any regular expressions now, because we didn't really cover that. Regular expressions for us have been utilized as like a tool, and they haven't really been something we've leaned into in that regard. Okay, so here is the content. And I think what I'm going to do is I'm going to turn on code highlighting by saving this as a Python file, but I'm not going to run this. Or I can at the end, but I don't want to run this at first because we won't be able to run this during an exam. I'm just getting rid of all the white space. It's there because the exam, it's more helpful to read, but it won't run with all that extra white space. So let's just quickly save this on the desktop as test.py. All right, we get code highlighting, and that's all nice and pretty. Let me make that a little bigger so we can see it a little better. Okay. So I think what I'm going to do is I'll use comments on the bottom of this file to kind of indicate the current state of things as we go through them. So first thing we have here is we have an object, we have a method, we have the main method which will get invoked. So we know just by looking at this program really quick that we are going to be invoking main first and then following the execution path of main. So the first thing that we do is we have this statement right here. And this statement here is invoking the foo constructor 2 times and placing both results inside of a tuple. So we're creating 2 foo objects here, and we can see right up here that foo objects, the constructor is defined as such. A foo object takes in 2 parameters, a and b, and stores them in instance variables a and b. And so we have 2 foo objects with their a and b instance variables defined, and we store a tuple of these objects into X. We then invoke method blackbox. Blackbox takes this tuple and a value of 4. We then come into here, and blackbox, here we have our comparator. I'm having a little brain fart. List comprehension, thank you. I'm like, I know what that is. So here's our list comprehension here. And now here's the thing about list comprehensions. This is kind of bulky, it's kind of dense. We do cover them on a lecture slide, but what if, oh shit, I don't remember what the lecture slide looks like. Now list comprehensions are relatively parse-outable, relatively. We've got 3 parts here. We've got n, n.a plus n.b. We have for n in y, and we have if foo.x equals n.x. Okay? So, so what we can see here, right, is that if foo.x is equal to n.x for n in y, then we do a summation of both of their values. Okay? So let's start here with our loop. Make sure we understand what we're iterating over. So when we do for n in y, y is this parameter, which is the first element, and black box, the first parameter, has an argument value of x. X is these foo objects, right? So in this case, y is a tuple with 2 elements, both foo objects. So for n in y is a loop that will loop twice, where n is a foo object each time. We can check our if statement condition here, right? So if this is true, we do this action on the far left. And our condition here is if foo.x is equal to n.x. So this is kind of a trick, because foo.x is the class variable right here. And n.x is also the class variable right there. Because if we are invoking n.x, what we are basically saying is we are getting the value of the x variable from object n. And because object n does not have an instance variable named x, it defaults or falls back to the global variable named x, which is still going to be bar. So this is going to be true for both loop iterations. Both iterations, the name of the class variable is going to be equivalent to the class variable in the individual object, right? Because there's no instance variable of x shadowing it over in either of these objects. Yeah. Now, the idea here is this is foo.x. So this is the value of the class variable. This is n.x. So this is a potential instance variable. If no instance variable named x exists, it falls back to the class variable. So if I had done something finagly down here and said x at 0 dot x equals foo, then this would become false all of a sudden, right? Because foo.x would still be bar, but n.x would be foo, and then that would be false, right? But because we don't have a statement like this, foo.x and n.x end up being the same value on both loop iterations. So we end up doing a plus n, or excuse me, n.a plus n.b. So we're concatenating the 2 instance variables in our foo object. So what we have stored in A at this point in the program's execution is we have our first object, which is hello world. So we have a string, hello world, and then we have another string, exam3. Okay. Believe this is a list, not a tuple. And so this is the list that we ultimately end up having. And then we come down here, we say y at 0.x equals z. So y being here, at 0 being the foo object, dot x being an instance variable equals z, which is going to be 4. So we're basically overriding the class variable in this first foo object with an instance variable named x. This is a red herring. Yeah, doesn't come up again. This is useless. It doesn't do anything because we never actually touch our foo objects again, right? Because after here, when we use them in the list comprehension, the return statement here is returning a, which is a list of strings, and foo.x, which is a string, which is the class variable. So doing y at 0.x equals z is it's an accurate statement. It does do the thing. It just doesn't really change the outcome of our program, right?
Because you're not returning just a dead fish.
Yeah, exactly. So.
And you're saying A is hello world as exam 3?
Mm-hmm.
How? Because if foo.x and n.x are both bar, then how can you be happening?
Because if this is true, then this gets executed. Yeah. Bingo. And so when we come down to the return statement, right, we're returning the value of a, which is this, and we're returning foo.x, which is just a string bar. So now this is a tuple with two elements, a list of strings and an individual string object. So then when we come down here, the value that is stored in B is going to be a tuple where the first element is a list, and the second element is a string. And so when we go to print this out, we are able to do for q in B, print q. So the first element is going to be, right, hello world. And the second output is going to be bar. And that's what this is going to look like, right? So this is your final answer. The first line is going to be hello world, comma, exam 3. It'll print out the full list. The second element is going to be bar. And that's what your final output for this is going to look like. Yeah, I can do that. And then I want to talk, before I get out of here today, I do want to talk a little bit about Python, or excuse me, about Java, because there were some, I feel like some things I want to correct the record on. No, just let me. All right, same principle here. So what we're looking at here is we're defining a function called blackbox, which takes in two default parameters, two required parameters, and a optional parameter. And we see here that we have an if statement, and then we have a recursive call. So honestly, this thing's not that hard to parse, in my opinion. The challenge is just remembering the rules of common list evaluation, which you always evaluate S expressions inside out. So let's take a look. I want to just invoke this and then go right for it. So we invoke blackbox and we give it two S expressions that are not evaluated. So basically two singularly linked lists of length 3 in both counts. Two lists of length 3 to get my number of fingers in my hands right. And so what we're looking at here is a list of 2, 8, and 64, and here a 16, 8, and 4. So we come in here, and this first list is list 1, this second list is list 2, and then we check if. So basically, you see if, or, no, list 1, no, list 2. We evaluate these inside out. So null, list 1, null, list 2. So if list 1 or list 2 are nil, and you see we have the or here, so it's either one of them, then we just return new list. So this is our base case, basically, right? So as we iterate over these lists recursively, eventually we will run to the end of one or both of these lists. Because recall, the end of a singly linked list in common Lisp is always nil, right? The CDR of the last con cell is always storing nil if it's the last element in the list. So by checking if list 1 or list 2 is nil, or that basically tells us that we have no more elements to iterate over, we are done, return whatever accumulated value is there. So that's our base case, and this is our recursive call. We'll note here really quickly that this is a recursive call, meaning that although it's indented, this is not happening sequentially as if it's an imperative language. This is the parameter, or excuse me, this is the argument for list 1. This is the argument for list 2. This is the argument for the new list, right? So by indenting it, it's just to kind of make it not look like a super ugly line sprawl of nightmare fuel. But what's actually going on here is that we are generating all 3 of the argument values for the recursive call. So for list 1 and list 2, we're simply passing in the CDR of list 1 and list 2. And this makes sense because by passing in the CDR, we're passing in the sublist of list 1 and list 2. The sublist being every element except the first one. So basically on each recursive call, we will go over and we will have one less element on our lists. So on the first recursive call, if we have 2, 8, and 64, the CDR of that is just 864. On the next iteration, if we have 864, the CDR of that is just 64. On the next iteration, if we just have 64, the CDR of that is nil. And if the CDR of that is nil, then that's going to evaluate to true, and we're going to hit our base case. So that's what's going on over here, right? List 1 and list 2 are allowing us to, on each recursive call, go forward in the singly linked list. And then we have our friend, the big ol' ugly answer generator going on here. So what this is saying is we are appending a con cell to our new list. Okay? So
we have a new list, and then we have basically a linked list within a linked list for each CDR of list 1 and 2.
I wouldn't say necessarily a linked list within a linked list, but you have the right idea, yeah. Because what we have here, right, is currently, let's look at how this con cell is going to get built, okay? So this con cell here is going to be, whenever we're creating a con cell, we're creating 2 elements, right? We're creating the car, and we're creating the CDR, okay? Now, the first element of our cell will be the car. Now, the car here is going to be the car of list 1, the car of list 2, and a division. So we are dividing the car, or the first element in list 1, by the first element in list 2.
Which would be 2 divided by 16.
Yes. So 1 over 8. And then that is our resulting con cell. A car of 1 over 8 and a CDR of nil. That is now appended to new list. Now here's the trick that I think a lot of people, I was not very harsh about this, but it is worth noting that the con cell is the first part of that append, right? So even though we're doing 2 divided by 16, we now have 1 over 8. So how do I want to do this? So basically, after our first recursive call to black box, we have a situation like this. List 1 is equal to a list of 8 and 64. List 2 is equal to a list of 8 and 4. And new list is equal to 1 over 8. Okay? So these are the values after the first loop iteration. Then we come down on the second loop iteration and we check. Is list 1 or list 2 nil? They're not, so we do another recursive call, right, where we advance the value of list 1 to simply be 64. We'll advance the value of list 2 to be 4, and then we'll calculate a value of new list. Now, I'll remind you that these are generating the arguments. They're not happening sequentially. So this CDR list 1, CDR list 2 doesn't actually modify list 1 and list 2 until the actual recursive call. Right? It doesn't modify the underlying list. It's just on the recursive call, the recursive value is the parameter is going to be different because it's a new function call. So there are new values in the parameters, even though they have the same name. We're not changing the underlying data structure. We're creating new ones and then passing them to the recursive call. Because the only reason I say that is just because when we come down to this append here, when we do the car of list 1 and the car of list 2, that's 8 and 8. Okay. So 1 over 8 comes from dividing 2 by 16.
But we're doing CDR list 1 and CDR list 2, so don't we skip over 2 and 16?
No, that's my whole point. This doesn't happen until the actual recursive call. These are not happening sequentially. These are all happening at the same time. So in the first loop iteration, you're storing the CDR of list 1 as the parameter for the call. You're storing the CDR of list 2 as the parameter for the recursive call. And then the state of list 1 and list 2 at this point are still the original values. Yeah, so it doesn't change. So that's my point. So now when we come in the new list here, right, the new values of list 1 and list 2 are going to be 64 and 4, but they're still currently these values when we're calculating this new list. And so new list is going to do the same operation of 8 divided by 8, and it's going to append that to new list. Now here's kind of the secret here. You'll notice that new list is in the back, so if we're going to do an append, it's actually going to be 1 divided by 1 over 8. Technically, it's separated by white space, but it's 1 over 8. Because when we come here, right, we come in and we check. Is list 1 nil or is list 2 nil? They're not. They're 64 and they're 4. And so then we come down here, and then our next recursive call, right, we do the CDR of list 1, which is going to be nil. We then do CDR of list 2, which is also going to be nil. And then we do new list. Now new list is going to take the value of 64 and the value of 4 and divide them, right? And so 64 divided by 4 is 8. And so it would just be 8, 1, 1 over 8. It's not moving anything. It's simply you're appending a con cell and new list. If the con cell comes first and the new list comes second, then that means you're appending new list to the back of the con cell. So this is reversing the order. Now granted, if you got those answers just in the wrong orientation, I think I took off half a point out of 10. Wasn't trying to be a little persnickety asshole about that. That's just kind of how the program worked out. If you got the right numbers, you got almost all the points. Because I didn't feel, actually that's not, is that really, I don't trust my ability to do basic math. I also don't trust Spotlight's ability because calculator and calendar are so similar. So depending on what characters you type in, CA will bring up the calculator, CAL will bring up the calendar, even though they're both fucking CAL. Don't understand why that is what it is, but I just don't feel like doing my mental math right now. Thought I was wrong. There you go, look at that, much better. So ultimately, we come for one last recursive loop, and list 1 and list 2 are nil. So this returns, and we just return from black box new list. So, we return our friends 16, 1, and 1 divided by 8. And that's your final answer. Okay. So, some of the individual components there of, the fact that the append is reversing the list, that stuff's subtle and, again, didn't really take very much off at all for something like that. If you miss something like that, that's not a huge deal, right? That's not really the point here. The point is more the basic mathematical understanding, right? The idea that on each loop iteration, we're making a recursive call, which is ultimately going to allow us to increment through the input lists and generate a resulting set of data. And yeah, it's going to be 16, 1, 1 over 8. And it has to be 1 over 8, by the way. Writing a decimal number is wrong. Because there are decimals in Common Lisp, but if it's something that can be resolved to a fraction, Common Lisp will keep it as a fraction, and they will not make it a decimal. So yeah, that's your Common Lisp program. Yes. Let me pull that up. All right, so this is our pal, our friend, using the grammar below. How many legal sentences are there? Why is that? And I'm going to ignore the second part of this question because that's a lot less important here. Main part of the question here is using the grammar below. How do we calculate how many legal sentences there are? And the answer to that is we simply build a tree. And I'm kind of debating here of whether I want to actually attempt doing it or if this is just going to be too much work. I'm going to try, for 3 seconds to see if I can actually pull off using this damn little tablet. Because if it don't play nice, I'm not going to bother. But if it do, it might make things a little easier. Oh. Please play nice just for a moment. Cool. Glad I brought the tablet today. So here's what I want to look at, right? When we're doing something like this, we don't have any regular expressions and we don't really have any recursion. That's kind of your first tip-off here, right? Because if all of a sudden I had something like a sentence breaks down into a noun phrase in another sentence, infinite. I don't need to do any analysis, right? Because if a sentence breaks down into itself, it can do that an infinite number of times. There's nothing preventing it from just looping forever. The outputs the outputs might not be very sensical, but that's not what we're asking here. So right off the bat, we can tell that this is going to work simply just because there is no recursive loops anywhere in this grammar. So the way I would want to derive this is I'll just do a parse tree and watch kind of how the trick is. So we see that a sentence breaks down into a noun phrase and a verb phrase, right? I'm going to try to make this tree as not terrible as I can. A noun phrase breaks down into an article and a noun. And a verb phrase breaks down into a verb and a noun phrase. The noun phrase breaks down into an article and a noun. And now, that's it. Articles, nouns, and verbs all break down into terminals, of which there are a finite number. It's not defined by a regex or anything like that. And so what I'll do here is, instead of normally when we're doing these trees, right, we actually just put the actual terminal values that they evaluate to. But in this case, that's not what we're trying to do. We're trying to calculate the number of possible combinations. So what I'm going to put here instead are the number of possible combinations for all of these non-terminals. An article has 3 options. It can be a, and, or the. A noun has 5 options. It can be any of those 5 words. A verb has 3 options. Article has 3, noun has 5. Yep. So all it's going to turn into, I'll just do it right down here, is it's just, 3 times 5 times 3 times 3 times 5, or 3 cubed times 5 squared. And if we want to do 3 cubed times 5 squared, can I? There we go, 675. And that's your answer. Yeah? Yes. Like, not to get too semantic, but for our purposes, yes. If there's a regular expression in the grammar at all, we'll just call it infinite. Technically, some regexes are more finite than others, and I'm sure if you're a mathematician or someone who's really about this, you know what I mean? Sometimes technically a regular expression could still have a finite grammar. But for our purposes, if we see a regex, we'll just call it infinite. I don't want to split hairs here. If there's a regex, the number of possible combinations may as well be infinite for what we're talking about in here. I know there's a whole class of regexes that have fixed number of character sizes, and technically, yada, yada, yada. I would not give you anything like that. That's an interesting theoretic question, but like for our purposes, if you see a regex, you can just assume it's infinite. I just can't help myself but put a little disclaimer and say that we're doing that for the class, and that I'm sure in the real, I say the real world like anyone does that type of analysis in industry, but as an academic, I just can't help myself. I take the bait too easy. So, anyone else have any questions? Because I have a couple of things I want to mention if no one else does. Because really quickly, I want to clear the screen. I would like to clear the screen and drawing again and knock that off. Java. There are a couple of things about Java that I noticed a lot of people got wrong on the exam that I want to clarify. And that is mainly all of this, the lambda stuff. And every year, by the way, I just kind of want to put on the record, every year this happens. Every year, it's usually kind of rough on the third exam. So I want to go through and clarify. So I'll just start with the second. I'll start with the first, right? An anonymous inner class is simply the defining of a custom class without a name inline, right? So inside of a program, you're defining an anonymous class on the fly that gets used once and has a custom behavior or implementation. What is a functional interface in Java? A functional interface is an interface with a single abstract method. Know the design pattern of lambda expressions relative to functional interfaces. And this is where a lot of things started to go awry. Most people recognized that there was a relationship or a link, but most people couldn't really tell me why. And what is happening here is that lambda expressions are related to functional interfaces because you can only utilize a lambda expression for an argument that takes a functional interface. So the data type of the argument needs to be a functional interface, right? That data type needs to be a functional interface for you to use a lambda. Because what a lambda does is it implements an anonymous object which, it instantiates an anonymous object which implements the functional interface. And because a functional interface only has a single abstract method, the lambda expression instantiates this custom object which implements the functional interface and overrides the functional interface's single abstract method. So what a lambda expression does is it's creating an object which implements an interface. And we can give it the method body implements the abstract method. The reason that lambdas are relative to functional interfaces is because if you have a functional interface, that means you only have one abstract method, meaning you, the programmer, don't need to specify what you're overriding. The compiler can infer it. That's kind of the beauty of lambda expressions. Because they only work where you would place an object that implements a functional interface, there is only a single abstract method that needs implementing. And so the lambda expression implements one function. You don't have to name that function or anything, because that function will always be the functional interface's single abstract method. That's the only thing a lambda can implement. And so, can lambda expressions create functions as data? No, because what they are doing is they are instantiating custom objects which implement a functional interface and override that interface's single abstract method. It's a huge word salad of nonsense, but that's what happens when you try and implement pseudo-functional constructs in a language that fundamentally doesn't support it. Yeah. In a sense, a lot of times that's how they get used, but truthfully, at the end of the day, all it really matters is just you're instantiating an object which implements an abstract method, not creating a function as data.
Can an anonymous inner class function as itself?
Yes. And here's the other trick. Can you substitute out a lambda every time there's an anonymous inner class? No. You can only substitute out a lambda when an anonymous inner class is implementing a functional interface. If an anonymous inner class isn't implementing a functional interface, you can't swap it. Because lambdas can only implement functional interfaces because it uses the specific parameters of the functional interface to infer everything. Because there's only one abstract method, you already know the method's parameters and its return value without having to say any of it. But if you have multiple abstract methods, that falls apart. If you're implementing an anonymous inner class that doesn't implement a functional interface in any way, well, then you can't use a lambda. So you can't just interchange them. Now, a lot of times you do because functional interfaces are designed into Java. A lot of the Java classes, a lot of the Java API stuff is designed to use functional interfaces so that it is easier and lambdas have a more widespread user base or potential use case base. You know what I mean? The Java language and a lot of the libraries built for it are designed with this paradigm in mind. So a lot of them take in functional interfaces to allow you to use lambdas. But if for some reason you ever need to implement an anonymous object that doesn't implement a functional interface, well, then you have to use an old school anonymous inner class. You can't use a lambda if it's not implementing a functional interface. So that I wanted to clarify. Yeah.
Out of curiosity, and if you know, in like the real world, if you're using like Java in industry, do anonymous inner classes get used a lot, or is it just kind of like one of those things where it just comes up every once in a while?
I would imagine it really depends on how shitty and old your Java code is. Because if I'm going to talk about industry, you got a lot of legacy Java. If you have a modern Java program being built within the past 3 to 5 years, I would imagine you're not going to see very many anonymous in your classes unless someone's an idiot. Because Java is really, recently anyway, the APIs and the libraries that are provided by Oracle are really designed to take advantage of this functional interface Lambda paradigm. And so a lot of things take in functional interfaces. So in a modern, properly built Java program or enterprise system, you really should see mostly Lambdas, and you really shouldn't need to see very many anonymous in your classes. Those should be rare. But that provides that it's new build and built well. And in industry, that's a big if. So in theory, yes, but who knows? But yeah, so that is roughly speaking the main takeaways I wanted to remind everyone about Lambdas. It's a really kind of obnoxious, esoteric process in a lot of ways, but that is how it works, and it's important to know that. I mean, like everything else I was pretty happy with in terms of the exam. I mean, like again, anything on this bullets, anything on these study guides is fair game. Definitely going to see some stuff I didn't include on the past 3 exams on the final. You're definitely going to see some stuff that I did include on the past 3 exams on the final. So, but those I know we saw once. I know we'll see it again, and I wanted to make a point to talk about it. Yeah.
First one, what are the odds that there would be like some like vocabulary type thing that wouldn't be on?
The odds are 0. Unless I do something stupid. The idea is, if you go through these 3 study guides and you like fill out these like bullet points, you come down here and you actually answer everything, the exam should be nothing but a cakewalk. If you go through and you actually can go through these bullet point lists and you can answer all of these, if it's understand how synchronized keywords works and you can understand it, right? Define Java reflection, you know how to define it. If you can do that for every bullet point on these lists, the exam, you should be able to knock a grand slam. Not just pass, like you should be able to knock this fucker out the park. So that is really the idea. I built these study guides first, and then I built the exam second. Because this really does encompass everything I want you to take away from the class. Because I know in lecture sometimes I do it for a lot of good reasons, but it can be rambly, tangenty sometimes. So I like having these kind of central repositories of information, and I'm like, this is what's fair game. I don't want people parsing through my lectures and finding me rambling about the Civil War and be like, do I need to remember that? Sure, if it helps you, but this is the core material. So yeah, if it's on here, it'll be on the exam. If it's not on here, it won't be. Yeah, I just say that because different people take exams at different times and it can be very, very hard to be like, this will take X number of hours. The way I do it is I always take my exams. This is something I learned when I was an undergrad, and I'm taking advice from one of my old professors. I take the exams before I give them all to you. And considering I'm teaching the material, I should be able to do it in about 1/4 of the time. So if I'm going to give you all 15 minutes, 50 divided by 4, some not precise number. And if I can get the exam done in that much time, I think it should be good. And if I can't, it's probably too long. So I do the same thing with the final. I go through it. I make sure that I can do it in like 30, 40 minutes if it's like a 3-hour exam, something like that. And then I think I'm competent with a number of questions, but it can be very hard for me to estimate how long it'll take for people, because sometimes people fly through, sometimes people stick through it, and that has absolutely no correlation with how well people do on the exams. Some people fly through and they do great. They just know everything. Some people go slow, and it's because they know everything. Some people fly through because they have no fucking clue what's going on, and they just want it done. Some people don't really know what they're doing, and so they're going to sit and fret over it until that last second. So it can be kind of hard to get a gauge. So that's my thing. I try and aim. I don't want everyone cramming their hands at the end of the 250 mark to try and get it all in, but I'm also stretching my legs. It won't be a 50-minute exam. Yeah. I mean, like, the due date is there so that people have an incentive to get it done before finals. But if anyone needs an extension on assignment 8, because I know our exam's right around the corner, email me. I'll give it to you. Honestly, that's a lot of times how it works. A lot of times I'll keep the dates where they're at because they are milestones I want to hit. But like, especially now that our final's early, if you need extra time on assignment 8, I'm more than happy to give it. I have a hard limit because grades are due, but I can give, if you need a few extra days on assignment 8 to prepare for this instead, then like, I'm more than about that. Just let me know. I do have a question in YouTube chat, which is how many questions on the exam? I don't know, like 50. Again, though, that's always not a great metric because I can give you a bunch of, true, false, or quick fill in the blanks, which don't really take any time. And then I give you 2 problems that are code problems that take like 20 minutes. So I think it's around 50, but again, that's not always the best metric. I'm, again, trying to keep it like a pretty decent balance between longer questions and more mild, just kind of fill in the blank, true, false stuff. Try to make a nice general balance. General balance. Also, just a quick reminder that the diagram nonsense will also be in play. Definitely note that you will almost certainly have to make some type of diagram on these exams. So again, my advice, especially if you're worried about time, is to take the test exam and get a little familiar with that diagram website. It's a lot easier if you go into the exam and you just got to build it and you don't have to take 15 minutes wondering to yourself, okay, the hell do I use this web app? You'll have to make either trees or symbol tables or both because those are the only things we use the diagram website for. But just like a fair warning, the diagram website will be there. That will be on the exam. And yeah, there's not a whole lot of things we use that for. So that does kind of imply what you might need to study for in that regard. So yeah, that's that. And again, the exam will be open all day Friday and all day Saturday. Anytime within that 48-hour period, you're allowed to take the exam. Again, if you have any technical mumbo jumbo you need to talk with me about, just DM me on Discord or shoot me an email. I will be extra specially checking on Friday and Saturday. Yeah, oh God, shit. I will be checking on Friday and Saturday. You'll have better luck in the earlier part of the day. If you DM me 10 p.m. on Saturday, I will be in Nova, and I probably won't be sober by 10 p.m. on a Saturday, but I will do my best. So I will still be checking my phone, but just a fair warning, it is a weekend, and I am decompressing a little. So just kind of that balance of I'm still checking my phone. I don't want anyone to completely panic. On the other hand, if I don't respond right away at 10:30 at night, there is a reason for that, and I don't want to pretend that there isn't. So yeah, that's it. This has gone quite well. So Friday, we can come back here. We can do this again Friday, or we don't have to. If you guys want, I can just ask on Thursday in the Discord. I know not everyone uses it, but there's only like 12 of us, 13 of us here right now. So like tentatively we'll have class Friday just to do more review. But if you guys are in here and on live stream again, so I'll plan for that. If y'all are good, I might double check on Thursday to see if anyone's actually going to show up. Yeah, by default, I'll just be here. You know what? I'll just be here because I'm realizing I have a faculty meeting and I would like an excuse to get off the damn call. And this does that for me. So, yeah, we'll be here Friday, and that might go really short if anyone has any questions. But if we have another slew of questions, then I'll be here all through. So thank you all so much for coming. Best of luck on the final. And yeah, if you have any questions between now and then, just DM me or email me. And yeah, if you need an extension on assignment 8, just DM me or email me. All right. Bye, everyone.